Hello guys, Namajo Singh this side from NetClass. So in this short video, we will discuss about IP addresses. We will learn about IP addresses, how things work, different classes of IP addresses, need of the IP address, and how this is derived from. So let's deep dive into this and let's have a look on it, and we will learn by seeing it. Okay. So talking about the IP addresses, let's see how this IP address comes from. Okay, let's start. So IP address. What is IP address? It is the identity of a node. What is a node? Node is simple computer or anything that can be connected to internet or can be connected in a without internet also. It is a node. The endpoint is known as a node. So IP address is the identity, but what kind of identity it is? It is a logical identity. Logical, what logical means in English dictionary, logical means that is not physical, but conceptually it is there. So it is a logical identity of a node. For example, you have a PC and or you are a person is having a name Naman. Same is the case with PC. A PC is having a name of IP. Just in analogy, there are few more concepts in between as well, like MAC address, that is also identity, but that's a physical identity. Physical means the real identity. Okay, so let's say IP is the logical identity of this node. For example, we are living in a world or in an office, I would say, we have different nodes, nodes 1, node 2, node 3. So all these nodes have different IP addresses. So all of these have a unique name, a unique logical identity of these nodes. Okay, and this is all about what basic IP address is. Now we will discuss about IPv4. You would have known about it, you would have listened about it. If not, then it's okay. There is IPv4. What is the significance of V4? V stands for version. So now we are living in a world. Now we are living in a world. Okay. Now we are living in a world where we are using IPv4 and IPv6. Need of introducing IPv6 is IPv4. Why we introduce IPv4? Because let's say in a world when we are booming the internet, we were not aware how many nodes would be, and eventually it end up being a cyber world. So in cyber world we see that okay, there are a lot of nodes now, and we are giving each node a unique name. That unique name is IP address. So once this IP address will become absolute in future, and there will be some nodes which we will not have name to give. For example, if we say we have IP pool, we will see how many IPs we have in IP pool, or a lot of IPs we have in IP pool, but there are a lot of devices also in this world. Device would say even from a watch to your PC to your cell phone. Okay, and each node is given an IP address. In future it will become absolute. This IP pool will be exhausted. So we introduce IPv6. We will see what is IPv6 and IPv4, the difference between them. But talking about basics, there was some name, some database name IPv4. Then we introduced IPv6 because IPv4 will become absolute in future. So about IPv4, we will discuss about this. This will stay in this world for a long time for sure, because it has already been assigned to so many nodes. So let's see what is IPv4. Talking about IPv4, we have divided this whole pool of IP into some categories. Those categories we call classes. Why we need classes? We will answer this question in the upcoming part. So classes we have A, B, C, D, E. These are the IP addresses. Classes of IP addresses. So how this works is basically, for example, you have a pool of IP addresses. This pool, every address of this pool is represented by bits. What is bits? Ones and zeros. On and off, ones and zero, the binary language, the language which computer understand. What we understand is a decimal language like 1, 2, 3, 10, 11, 19, 68. So this every IP of this pool is represented by bits and bytes. Every IP of this pool have 4 octets. What is octet? Octet is a set of 8 bits, means set of 8 ones or zeros. Okay, in total every address of this IPv4 is 32-bit length, and maximum it can go is 255. We will again see how in the future. Okay, and 32 is why 32? Because 4 octets. I will explain. So let's say we have a IP address. How we get IP address? How we know what is the IP address of our node? Go to the command prompt of your PC. If you are using Windows, then type IP config. If you are using Linux, then type ifconfig, ifconfig. So in this you can get this, let's say this, okay, you know this. So these things you say, what are these? These are the IP addresses and the things which we use. Okay, let's see. Okay, so this PC which I am using, let's suppose it's have IP address of 192.168.2.13. Let's take a screenshot of this. That would be more good. Okay, let's try it here. So we have a, or this is, we are talking about our PC. So our PC is having a IP address of 192.168.2.13. How this number comes from? As we know, it is all about ones and zeros, 4 octets, means ones and zeros of 4 octets. Let's talk about 1 octet first. 1, 2, 3, 4, 5, 6, 7, 8. So this is 1 octet. 8 bits, 4 octets. Then 2, 3, 4, 5, 6, 7, 8, another octet. 1, 2, 3, 4, 5, 6, 7, 8, another octet. 1, 2, 3, 4, 5, 6, 7, 8, another octet. So in total, how many octets are there? This is octet number 1. Yes. This is octet number 2. Obviously. This is octet number 3 and this is octet number 4. So how many octets are there? 4 octets. How many bits are there? 8. 8, 8 and 8. 8 into 4, 32. 32 bits. So it have 4 octets, it have 32 bits, it is a series of ones and zeros, maximum value is 255. This question we will answer. How this value come from? Let's break down one octet. 1, 2, 3, 4, 5, 6, 7, 8. We are taking this octet. So this octet is, you know how to convert binary into decimal, right? So it's simple. 2 raised to power 1, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 3, 4, 5, 6, 7. Seventh bit. If there is 0, 0, 0, 0, 0, 0, 1, so the value would be 1. Let's say this is 2, this is 1. This is 1, 2, 4, 8, 16, 32, 64, 128. So this is the value. When we are talking about this, so when we say bit is either 1 or 0, we say bit is either on or off. If bit is 1, then it do have a value, and if it is 0, it do not have a value. How so? Let's say we have 8 bits, we do this one, this bit 1, and all other bits are zeros. If all other bits are zeros and only these 2 bits are 1, so that means these 2 bits are having a value. So these 2 bits would add up. How this will add up? The significant value of these bits. So this bit is having a value of 128, and this bit is having a value of 64. 192. So this 192 come from here only. So if we are saying we are representing 192.0.0.0, this is for our understanding, because our eyes or brains are used to learn about it. We are programmed in such a way we are good at remembering decimal values. But in backend, in physical layer, in backend, it is a series of ones and zeros. 1, 2, 3, 4, 5, 6, 7, 8. Same. Okay, 8 times 0. So this is how it works. When we are talking about an IP address like this, let's take it again. Let's take it again. If we take this IP address, okay, yeah, so I'm back. So let's take the example of this IP address 1 into 162.1. Let's convert this IP address into the binary form. Let's how into bits and bytes. Let's take the 192 first. How we convert 192 into binary? Very simple. You would have done this in 5th or 6th standard. 2 4s are 9 2s are 18. 2 6 are 12. Remainder is 0. So you make this divided by this. The remainder is 0. How? Let's say 192 divided by 2 is 96. 2 into 96 is 192. The remainder is 0. You put the remainder here. Again, 2 4s are 8, 2 8s are 16. Again the remainder is 0. Why? Take this number 96 divided by 2. 2 4s are 8, 2 8s are 16. 2 into 48 is 96. The remainder is 0. So you do 2, 2, 4. Again the remainder is 0. Again you take okay, 2 ones are 2, 2 twos are 4, the remainder is 0. 2 6 are 12, the remainder is 0. 2 threes are 6, the remainder is 0. 2 ones are 2, and the remainder is 1. So you study like this, or this is the least significant bit. Least significant bit means the ending bit. So 0 0 0 0 0 0 1 2 3 4 5 6 and 1 and 1. You represent simple. I hope you get it. You represent 192 by 1 1 0 0 0 0 0 0. It is simple as that. So simple. You learn how to represent a decimal into binary, and this is all about IP address. IP address is all about this. So you take this 192, you break like this. Let's take the other part, this part, 168. Sorry. Let's take this part, 168. Let's do the rough part here. 168, 2 is the 16, 2 4 is the 8, 0, 2 4 is the 8, 2 2 is the 4, again remainder is 0, 2 2 is the 4, 2 1 is the 2, again yes, the remainder is 0, 2 10 is the 20, the remainder is 1, 2 5 is the 10, remainder is 0, 2 2 is the 4, remainder is 1, 2 1 is the 2, and remainder is 0. So you represent like this. This is the least significant bit. 1 2 3 4 5 6 7 8. You represent like 1 0 1 0 1 0 0 0. Am I wrong? 0 0 0 1 1 0 1 0. So let's take this 1 0 1 0 1 0 0 0. 2 raised to power, this is not significant. 2 raised to power 0 is not significant. 2 raised to power 1 is not significant. 2 raised to power 2 is not significant. Let's say 2 raised to power 3. So 2 raised to power 3 is 8. 2 raised to power 4 doesn't matter. It is 0. 2 raised to power 5. 2 raised to power 5 is 8, 16, 32. 16, 32, 64, 128. So this is 2 raised to power 6 is again 0, doesn't matter, into 0. 2 raised to power 7 is 128. So you do the addition of this, simple addition mathematics. 3 4 5 6 168. So this is it. Again in a similar way, if we take 2 is representing 2 is simple, isn't it? You just need 2 ones are 2, and the bit is 0. So you do 0 and 1. And when you are representing 13, again we will take 13. 2 6 are 12, remainder bit is 1, because 2 6 are 6, 12. 12 minus 13 is 1. 2 3 is 6, remainder bit is 0. 2 1s are 2, 2 1s are 2, the remainder bit is 1. So 1 1 0 1. 2 4 8 8 4 13. Okay, but this is 4 octet of 4 octet, right? And 1 octet is 8 bit, so we need to represent 2 as 8 bits. So we will do 0 of the further bits. 1 2 3 4 5 6 7 8. Again same case, it is a 4 bit, we need to make it 8 bit, so the above the ahead bits would be 0. 1 2 3 4. So this is how you represent IP address of 192.168.2.13 as 11000000 10110000 0 1 0 0 0 0 0 0 0 0 0 1 0. Where was it? 1 2 1 2 3 4 5 6 7 8 and 0 0 0 0 1 1 0 1. So you are representing this in such a way. Let's see how Google can help us with this. Let's say to IP address, I would say. Decimal to IP converter. Simple. This is online tool. 192.168.2.13 it is, right? You click convert. This is something different. No. Oh, IP to binary. Online calculator. Let's see. 192.168.2.13 it is, right? So this is the representation. So in backend, when you talk about this is nothing but this. This is how you represent it. Okay, you can see it's same. So this is how you represent the IP address, and this is the significance of IP address. So when I was coming back to the question, why this question, right? Let's answer this question now. This question, let's say. Let's now answer this question. Why the maximum is 255? So the answer is, when you do every bit on, when you say 1 2 3 4 5 6 7 8 instead of any zero, how this adds up is 128 plus 64 plus 32 plus 8 to 16 8 16 plus 8 plus 4 plus 2 plus 1, so it adds up to 255, isn't it? 2 3 4 5 6 7 8, so these are 8 bits, so it added 255, so the maximum is 255. So we have answered what the IP address is. Now we know how IP address is represented to us and what is it in the background. And this is IPv6. See this IP address, this is the IPv6. We will discuss it in future. It is a more it is an easy concept, I would say, rather than IPv4. We have subnet mask. We will discuss about this also in the upcoming video. So this is all about how IP addresses work and what is the significance of IP addresses. So now learn about the classes. I was discussing about there is a pool of IP address. Like in pool of IP addresses, we have divided IP address in different classes. What is the need of IP address classes anyway? Any specific need we have? Yes, we have. So let's say we are in Toronto and someone is in Brampton. I am living in Scarborough and he is living in Sheridan. Scarborough and Sheridan, okay? I have my own office here. He have his own office here. There is an employee. and a lot of more employees we have, and a lot of more nodes we have. So this was about the types of IP addresses, not the classes first. Let's discuss about the types of IP addresses. How many types of addresses? Steps 2, private and public. As the name suggests, private is something that is private to do, and public is something that is public to everyone. So when we are discussing about office here, that is known as LAN, local area network, that has no connectivity to the internet yet. We can connect this to internet, of course we will. That is the whole point of using networking, right? But when we are discussing about local area network, we are saying we are living in an enclosed environment of known surroundings, and as those known surroundings, we have different nodes, and every node have a IP address. Here also, same with the Brampton branch, we have IP addresses assigned to the nodes. These are the public IP addresses, the private IP addresses. Why private? Because they are private. Naman can work in this office. People may know this person with the name of Naman. Same is the case with the Brampton office. People may know someone with the name Naman. They can address someone with the name Naman. But when they are going online and when they are going connecting to the cloud, they need some different name. There can't be a same they can't be two persons with a different same name online, right? So same with private address. This is the private address. But when we are connecting to the WAN, when we are talking about connecting with the internet, talking to the internet, downloading any file, sending emails, we are connecting to a WAN, and connecting to a WAN comes with the public IP address. Why public IP address? Because it is public, it is known to the internet. So we have divided classes of IP address into public and private. Why so? What was the need of it? We invented IPV4, the series of ones and zeros. So you can say series of ones and zeros can be in so many ways, in trillions, so many ways we can represent ones and zeros, right? So many ways, in how many ways IP addresses can be defined. But again, there will be one time when this will be absolute. All of the IP address will have been used by some nodes in future. So we divided IP address into classes A, B, C, D, and E, and again we divided A, B, C, let's say, into private and public, so that private can be used by everyone and public can be assigned. Public is a paid IP address, let's say, that is assigned by the ISP. And private. So that means if we have a IP address, let's say 10.10.10.10. Okay, let's take a small IP address. For example, this is a private IP address. We can assign it in LAN 1. We can assign it in LAN 2 as well. But LAN 2 would not have another node with the same IP address. It is not possible. You can't address two systems with the same IP address. It is possible in cybersecurity, but we are discussing about the basic concepts here, not the complex concepts. So this doesn't exist here. So LAN 1, LAN 2 have 10.10.10.10. Okay, but when sorry for this. Okay. But when we are discussing about connecting these two LANs, when we are connecting this with a WAN, in such way only these LANs can communicate. We need a public IP, and this public IP will travel on the internet to this and again to this. They both will have a public IP, and this public IP would also be different. Public IP is unique. For example, let's say 101.1.1.1 is public IP of this, 1.2 is public IP of this, and these both can communicate. So let's take this, the classes of IP addresses. This is the classes of IP addresses. So class A we have 10.0.0.0 to 10 to 55 to 55 to 55. See, in clock we have 359. After 359 there is not 360, there is 4 p.m. right? So in 4 p.m. is the same concept with IP addresses. After 0 there is no 1, 0.0 maximum. After 254 there is no 256. After 255 there is no 255. After 256, 255 there is no 256, there is 0. So 254, 255 and then 0. Same concept with the clock. So maximum value it can go is 255. So but in class A it comes as 10, 0, 0 to 10, 255, 255, 255. Same. Okay. Like this way is the private address range. But if we are talking about class A IP addresses, it is anywhere if you do all bits to 0, 0.0.0.0. Of course, if we have a pool, the very first IP of this pool would be 0.0.0.0, and the very last IP of this would be 255, 255, 255, 255. Why so? Because we are doing, once we are doing every bit 0 and then we are doing every bit 1. So talking about class A address, it is 0.0.0.0 to 10.255.255.255. Sorry. So let's talk about class A. It is so let's talk about class A address. It is 0.0.0.0 to 126.255.255.255. This is the class A address. In this class A address, we have some private also that can be used by everyone. So private is 10.0.0.0 to 10.255.255.255. Okay, this is the private in class A. Same is as with class B. In class B, as you can see here, we have IP address of 128.0.0.0 to 191.255.255.255. But in between this, we have a private range of this 172.16.0.0 to 172.31.0.0. 2.16.0.0 to 172.16.255.255. 31.255.255. So this is the private IP addresses. Same as the class C. Class C IP addresses to see this ends with 192, 191. So the next address will be 192. Again 192. So after 191, 255, 255, 255, there is not 192, 256, 256, no. There is 192, 0.0.0, because we are increasing this value and after. So 192 to 233, 223, 223, 255.255.255, and the private address is 192.168.0.0, 192.168.0.0 to 192.168.255.255. So 0 to 126 is class A, and with private addresses, of course. 0 to 126 is class A, 128 to 191 is class B, 192 to 223 is class C. Where this 127 go? After 126 there is no 127, there is 128. So 127 is a loopback IP that is used for the loopback IP is used for the troubleshooting purposes. For the troubleshooting, it's a loopback IP. We'll come back to it. It is used to check the connectivity of your PC only. So we have private addresses now. We have public addresses now of class A, B, C. Same is with class D and class E. As you can see in the chart as well, you should remember these IP addresses. So this is how IP addresses work. So let's do some exercise. Let's take a IP address. Let's see. Let's take a IP address from the system only. Let's take this IP 192.168.244.1. 192.168.244.1. Let's convert this IP into its real format, that is binary. And what class is this IP address? So let's talk about this class first. This class is 192.168.244.1. This class comes under class 6. How? See this table. If you can see, 192.168.244.1 is coming under this category. So it is class C IP address, and talking about its representation, 192 is represented as 192. Let's do the rough work. Let's do the rough work here. 192. 2 8s are 16. 2 6 are 12. 2 4s are 8. 2 3s are 6. 2 9s are 18. 2 6 are 12. 2 4s are 8. 2 3s are 6. 2 8s are 16. 2 2s are 4. 2 4s are 8. 2 1s are 2. 2 2s are 4. 2 6 are 12. 2 3s are 6. 2 1s are 2. 1 1 1 2 3 4 5 6. 1 2 3 4 5 6. 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, 168. We have done this before. Let's take 168. 2 8s are 16. 2 4s are 8. Remainder is 0. 2 4s are 8. 2 2s are 4. Remainder is 0. 2 2s are 4. 2 2s are 4. 2 1s are 2. Remainder is 0. 2 10s are 20. Remainder is 1. 2 5s are 10. Remainder is 0. 2 2s are 4. Remainder is 1. 2 1s are 2. Remainder is 0. 1 0 1 0 1 0 0 0. 1 2 3 4 5 6 7 8. Again with 255. 244, it is 244. Let's say 244. 2 6 are 12, 2 on the 2. 2 6 are 12, 2 on the 2. 2 3 6 2 0 1. 2 15 the 30. 2 7 the 14. 2 3 the 6. 2 1 the 2. 1 1 1 1 1. 1 1 1 1 0 1 0 0 1 2 3 4 5 6 7 8, and 1 is represented as 0 0 0 0 0 0. So 1 2 3 4 5 6 1 2 3 4 5 6 7 and 8. So 192 168 244. 1 is represented as 1 1 0 2 4 1 0 1 0 1 0 0 0 1 1 1 1 0 1 0 0 1 2 3 4 5 6 7 8. This dot is necessary because it's a 4 octets. This is 32-bit. Maximum value is 255. There are classes A, B, C, D, E. So this is how you break down an IP address. In further videos, we will discuss about another concept, that is subnet mask. Subnet mask goes hand in hand with the IP address. If we are discussing about IP address, learning about subnet mask is also very necessary. We will learn about default gateway. Default gateway is like the exit point of the traffic. We will learn about how default gateway is how it's decided. We will discuss about network and the broadcast IP. Just don't confuse yourself with the names, as IPv4 was seeming complex to you. Now you know how easy it is. Same would be the case with every concept coming further, and we will break this topic into little bit parts more, and we will learn a lot about IP addresses. So thank you guys for the support, and in the next video definitely we will discuss about the upcoming topics, and it will make you understand more about the basics concepts we are talking about here. Thank you.